You type a question into ChatGPT, you press enter, and a few seconds later an answer appears. It can explain physics, write code, tell a story, translate languages, and even argue both sides of a complicated question. But here's the strange part. Somewhere inside all of that complexity, the model is repeatedly making a prediction about what comes next. So how can predicting one tiny piece of text at a time produce something that feels like an intelligent conversation? The answer begins with something surprisingly simple. ChatGPT doesn't receive your sentence as one giant block of meaning. Your text is first broken into smaller pieces called tokens. A token might be a whole word, part of a word, punctuation, or another small piece of text. The model processes these tokens as numbers because neural networks don't understand text in the way humans see it. They operate on mathematical representations of information. Imagine I give the model this sentence. The sun rises in the. Even before seeing the answer, you can probably guess what comes next. East is a very strong possibility. But the model doesn't have a little dictionary entry saying sun rises in the east. Instead, during training, it learns statistical relationships between enormous numbers of pieces of information. It learns that some tokens are strongly related to others, depending on the context surrounding them. And this is where the first big misconception disappears. The model isn't simply searching through a giant database for a sentence that matches your question. During training, its internal parameters are adjusted as it repeatedly tries to predict missing or upcoming tokens. When its prediction is wrong, the mathematical process used for training changes those parameters slightly. After an enormous number of examples, the model becomes extremely good at recognizing patterns in language. Think about learning a language as a child. You aren't given a rulebook containing every possible sentence you will ever hear. You hear people speak. You notice patterns. You learn that certain words tend to appear together, that grammar follows structures, and that the same idea can be expressed in many different ways. A language model learns from patterns at a vastly larger scale, represented inside a huge mathematical network of learned parameters. Now comes the moment that makes the whole system possible. Suppose you type, the capital of France is. The model doesn't just choose one answer from a list. Internally, it produces probabilities for possible next tokens. Paris might receive a very high probability. Other words receive much lower probabilities. The model then selects a token according to its generation process. That token is added to the context, and the model predicts the next token again. So a response that looks like one continuous thought is actually generated step by step, token after token, prediction after prediction. First one piece appears, then that piece becomes part of the context used to generate the next one, then another, and another. The process continues until the model has produced the response you see on your screen. But there is a problem. If the model only looked at the immediately previous token, it would have almost no idea what your sentence meant. Imagine reading this. The scientist dropped the glass because it was. To understand what it refers to, the model needs information from earlier in the sentence. And in a long conversation, the important clue might be dozens, hundreds, or even thousands of tokens away. This is where the transformer architecture changed the game. Transformers use a mechanism called attention. In simple terms, attention allows the model to weigh different parts of the context when processing a token. Some pieces of information become more relevant than others, depending on what the model is trying to predict. Instead of treating every word as equally important, the network can build relationships between different parts of the context. Imagine the sentence, the trophy wouldn't fit in the suitcase because it was too large. What was too large? The trophy or the suitcase. Understanding the relationship between those words requires looking across the sentence, not just at the words next to each other. Attention helps a transformer connect information across the context. And when this happens across many layers and many attention mechanisms, the model can build increasingly rich internal representations of what the text is about. But attention alone isn't the magic ingredient. A transformer is a deep neural network containing many layers and learned parameters. During training, those parameters are adjusted so the model becomes better at its prediction task. Over time, useful representations of grammar, concepts, relationships, patterns, and other regularities can emerge from the optimization process. Nobody manually writes a rule for every possible sentence the model might encounter. And this is where things get really surprising. The model was not originally trained by being told, "Here is how to answer questions." A major part of pre-training is learning from the prediction task itself. By becoming better at predicting what comes next across enormous amounts of data, the model can acquire capabilities that are useful for many different tasks. Language, coding, translation, summarization, explanation, and other behaviors can emerge from the same underlying learning process. But a raw language model is not automatically a helpful chatbot. After pre-training, models can go through additional stages of post-training designed to make their behavior more useful, safer, and better aligned with human instructions and preferences. Human-generated examples, evaluations, reference data, and other training techniques can shape how the model responds to requests. So the system you interact with isn't simply a giant autocomplete engine left untouched after its initial training. Now think about what happens when you actually send a message. Your prompt is converted into tokens. Those tokens are processed by the model. The model uses the context available to it and its learned parameters to calculate what should come next. One token is generated. Then the process repeats. What feels like a single intelligent answer is produced through an extremely large number of mathematical operations happening very quickly. And here's the part that can feel almost magical. The model isn't following a giant flowchart that says, "If the user asks this, say this." It has learned a complicated network of statistical and mathematical relationships from training. When those relationships interact with your prompt and its surrounding context, the model can generate a response that wasn't explicitly written for you in advance. But does that mean ChatGPT actually understands what you're saying? That's a much harder question. The model clearly processes complex relationships in language and can perform tasks that look remarkably like understanding. But whether that should be called genuine understanding, reasoning, or something else is still a deeper scientific and philosophical question. What we can say with confidence is that the mechanism underneath is far more sophisticated than simply searching for an answer. So the next time you type a question into ChatGPT and watch the answer appear, remember what is happening underneath. Your words become tokens. Tokens become mathematical representations. A neural network processes their relationships. The model estimates what should come next. One token becomes context for the next, and this process repeats incredibly quickly until a complete response appears. The truly fascinating part isn't that a machine can predict the next token. It's that when you scale this simple learning objective across enormous amounts of data, massive neural networks, and powerful training methods, surprisingly sophisticated capabilities can emerge. And that leaves us with an even bigger question. If predicting the next piece of information can produce something that looks like intelligence, where exactly does intelligence begin? This is Curiosity Quest, where we explore the strange questions behind the technology, science, psychology, and world around us. If this changed the way you think about AI, like, share, and subscribe. Follow Curiosity Quest for more curious questions and surprising explanations. And until next time, keep learning, keep exploring.